so today we're doing polar coordinate. So let's suppose that we have a point a line from 0 to P, where and then between that is like an angle of delta. This is a direct angle, and and this is the polar axis. Let's suppose that this one from 0 to from O to P is the is r, the distance between this, and we can say that this can be as, we can replace this as r comma delta right here. So for how do we measure delta? We will measure counterclockwise, and we can remember this as C-A-N, counter clockwise, clocks always negative. Okay, let's suppose that we have this coordinate conversion thing, and let's suppose that this line is r, and this is clearly the y, and this is clearly the x. So let's and then this right here is theta. So how do we move back and forth? So let's suppose that this is a triangle. So we have our angle here, which is theta, and we can go on this. It can be so how do we find theta? So we can try to do tangent of theta equal to y, which is opposite, over adjacent, which is x. Okay, so how do we find the cosine? So cosine is adjacent over hypotenuse. In this case, r is the hypotenuse, and y is the opposite of theta, and x adjacent. So we can find cosine theta equal to the adjacent side, which is x, over the hypotenuse, which is r. And then we can find sine with the same thing. Sine is opposite over adjacent, so we have opposite is y. So sine theta equal to y over r, which is the hypotenuse. Okay, so how do we find the polar coordinate? So the coordinate conversion states that the polar coordinate of r comma theta of all the points related to the rectangular coordination of x comma y can be stated as the following. So in this case, it's the x equal to r cosine theta and y equal to r sine theta. This is how we express x and r. And then we can also express it in another way with tangent. Let's go tangent of theta equal to y over x, or we can express as r squared equal to x squared plus y squared. Okay, so let's look at the graph. So we have a graph, a collection of points 1, 2, and 3. And then we can draw like a circle around it to represent the graph. Okay, so our function in this one is this little circle right here, r equal 2. So what it is saying is that it's just r equal 2. The equation for this can be x squared plus y squared equal to 4. This is saying that for every x plus y squared, it will be the same, and for every collection of it will be the same, r equal to 2. Let's look at another graph. I'm gonna do the same thing. Draw the circle 1, 2, 3, 1, 2, 3. Draw a circle, and a circle. So with this graph, what if we have like a line going through it? So this vertical line have the theta of pi equal to 3. This is just saying the same thing as y equal to mx, the slope formula. And then let's look at our last equation. We can we have something like this. Draw a circle again. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So what if we have a vertical line going through 1? So the vertical line equal to r equal to secant theta, and this is the equation for this graph right here. So just say it's the same thing as saying, so let's express this. So x is equal to our formula, r cosine theta, right? In this case, x equal to 1, so we can express this is equal to 1 equal to r cosine theta. And how to find r? And then find r. R is just secant. So good. There you go. Okay, so let's look at the slope in polar form. So what does the slope in polar form look like? So the slope in polar form is just like, so what if f is a derivative of a function of theta, then the slope of tangent line to the graph of r equal to f theta at the point of r comma theta is dy over dx. It's the same thing as dy dx theta. And then so the formula for this is f theta cosine theta, and this is the derivative of dy plus, regular form, equation, and plus the derivative of f prime of sine theta over negative f theta sine of theta plus f prime of theta to cosine of theta. So this is a formula for slope for the slope of polar. So let's talk about the graph shape of polar. So we have let's start with the limit. So we have the limit as r equal to a plus and minus b cosine of theta, or r equal to a plus or minus b sine of theta, where a is bigger than 0 and b is bigger than 0. So what does this look like? What if a over b is less than 1? So we have a limit with an inner loop. So what if we have a over b, sorry, my a look bad, a over b equal to 1? This is where we having a cardioid, which is simply as like a heart shape. And what if we have 1 bigger than, big one, a over b bigger than 2? This is a Dirichlet limit. And then we might have something as a over b bigger than 2. This is a convex limit. So let's move on to rose petal. Okay, so let's do the rose curve. So for the n petal, if is odd. So what if it's even? Then we have 2 times n petal if n is even. So for example, if n in this case is 3, then we have 3 petal. What if n is like 4 or 8? So we have, if n is 4, we double it because it's an even number. So we have 4 times 2 is 8 petal. And what if we have 8 petal? This is still an even number, so we also double it, which is 2 times 8 is 16 petal. And we have a graph of 16 of rows of 16 petal.